Hello students, welcome to grade 10th chemistry class, periodic classification of elements. In the previous session, I have explained you about Mendeleev's periodic table. Now let's have a quick look at it to move ahead. Mendeleev's periodic table. This table is based on the classification of elements by arranging them in the increasing order of their atomic masses and similarities in their properties. 2 points were taken into account to frame Mendeleev's periodic table. So the 2 points are, first thing, atomic masses of the elements, and then next, similarities of the properties of the elements. So here the formula of oxides and hydrates formed by the elements was taken, and it was also the basis for this classification. So in the Mendeleev's periodic table, 2 points were taken into account. The first thing is atomic masses of the elements, and then next, similarities in the chemical properties of the elements. Then according to this periodic table, this periodic table has 6 horizontal rows called periods and 8 vertical rows called groups. So Mendeleev's periodic table has 6 periods and 8 groups. And of these 8 groups, 1 to 7 groups are divided into 2 subgroups as A and B, and 8th group is divided into 3 rows of elements. Elements having similar properties were placed in the same group. There are some places left vacant in the table to accommodate the elements that has to be discovered in the future. So the benefit or the advantage of Mendeleev's periodic table is that he could able to accommodate the elements which were discovered in merits of Mendeleev's periodic table. The merits of this table are the elements were divided on a more fundamental basis of their atomic masses and properties. So, what is the more fundamental basis is? It's a base of atomic masses and properties of the elements. And then spaces were left vacant to accommodate the elements to be discovered in future. So, he left places to accommodate the elements that could be discovered in future. It could predict the properties of the elements which helped in the discovery of new elements. So here when he has left places or he has spaces are left for the new elements, he could also predict the properties of those elements which help them to discover those elements. And then the other merit of this table is the inert gas elements discovered later could be placed in a separate group without disturbing the table. So the elements like inert gas elements were able to be placed separately as a separate group in the periodic table without disturbing the defects of Mendeleev's periodic table. According to Mendeleev periodic table, elements has to be arranged in the increasing order of their atomic masses. But it was observed that some elements are not arranged in the increasing order of their atomic masses. For example, cobalt and nickel. Here, cobalt atomic mass is 58.9 and nickel atomic mass is 58.7. So, nickel is having mass lesser than cobalt, but in the periodic table of Mendeleev, cobalt is placed before nickel. The same way tellurium and iodine. Here tellurium atomic mass is higher than iodine, but tellurium is placed before iodine. So here the sequence had changed. So this is a defect of Mendeleev periodic table. Then second defect or the other flaw in the Mendeleev's periodic table is position of hydrogen. Position of hydrogen is not clear because it shows properties similar to metals as well as non-metals. So here the position of hydrogen in the periodic table is not clear according to the Mendeleev's periodic table, because it was observed that the element hydrogen is exhibiting the properties with electronic configuration similar to alkali metals. It is resembling in the properties of alkali metals like sodium, magnesium, when they react with either oxygen or halogens. Like alkali metals, when they react with oxides, then they form R2O. The same way, even hydrogen is also combining with oxygen and forming H2O. The same way, when alkali metals react with halogens like fluorine, chlorine, bromine, anything, it forms the respective halide Rx. So in the same way, hydrogen is also forming the compound. So this reaction of hydrogen, similar to metals as well as non-metals, has not given a clear picture for the position of hydrogen. The next drawback is position of isotopes of elements is not clear. So here isotopes of some elements, you should be knowing isotopes. What are isotopes? Here I will be explaining in the next slide what are isotopes. So here some elements have or they exhibit isotopes. The position of them is not clear in the Mendeleev's periodic table. Now let's see what are the position of isotopes in the Mendeleev's periodic table is not clear. Now let's see what are isotopes. Before going to details of the isotope, let's go back to Dalton's theory. Dalton has proposed that all the elements of same type will have identical atoms. That means any element, like when you take two atoms of any element, will have identical atoms. But it was proved wrong when isotopes came into existence. Atoms of the same element can have different numbers of neutrons. We know that atom consists of subatomic particles like electrons, protons and neutrons. But it was proved later that atoms of the same element can have different number of neutrons. Thus, different mass numbers it will possess. And these atoms which are having different mass numbers are known as isotopes of the element. So, Frederick Soddy proposed the idea of isotopes in the year 1912. What are isotopes means? Isotopes are atoms of same element having different masses due to varying number of neutrons. So what are isotopes means? Isotopes are atoms of same element but they possess different masses due to different number of neutrons. So here atoms are the elements of same atom having different masses due to varying number of neutrons, and this was observed by Frederick Soddy in 1912, and he won the Nobel Prize in Chemistry in 1921 for his work with isotopes and radioactive materials. So I hope you are clear with isotopes. What are isotopes means? Isotopes are atoms of same element. It may be the atom of same element, but it will have different mass. Why they possess different mass is due to varying number of neutrons. Due to different number of neutrons present in them, the atomic mass changes because atomic mass is equal to number of protons and neutrons present in an atom. Since neutrons number is varying here, changing here, so the isotope will have different mass. Finally, to repeat or to remember what are isotopes means, isotopes are atoms of same element having different masses. And why do they have different masses? Due to varying number of neutrons in them. And who was observed this is Frederick Soddy had observed the existence of isotopes in the year 1912. And for this work he was given Nobel Prize. He won the Nobel Prize in 1921. That is after 9 years of his invention. So isotopes are the elements occur in nature as mixtures of isotopes. So the elements occur in nature as mixtures of isotopes. In general, elements they occur in nature as a mixture of isotopes, and isotopes are atoms of the same element that differ in the number of neutrons. So here isotopes means they are the atoms of same element that differ in the number of neutrons. Since the number of neutrons are changing, its atomic mass also will change. And we know that atomic mass is equal to sum of protons and neutrons. Now here are examples of isotopes. So here these three elements, hydrogen, helium, lithium, can exhibit its isotope. The isotopes of hydrogen is H11. You know that an element is represented with its atomic number and mass number. Here, since we are discussing about its mass number, it is represented as only with mass numbers. So here, hydrogen H11 denotes it possesses only one proton, and H12, which is known as deuterium, has one proton and one neutron. So here in this example you can see that the pink colored charged particle is proton and the green colored one is neutron. So here in this H12, one proton and one neutron is present. So together its mass is equal to 2. Now the third isotope of hydrogen is H13, which is known as tritium. And here in this atom there are how many protons present? The pink colored one? Yes, 1. And neutrons are 2 in number. So its atomic mass is 1 plus 2, 3. That's why it is H13. Have you got it now? So H11 denotes 1 proton and H12 denotes 1 proton and 1 neutron. H13 is 1 proton and 2 neutrons. So these are the isotopes of hydrogen. Now isotopes of helium. Helium is atomic number is 2. So here atomic number 2 represents or denotes the number of protons present in it. So here 2 protons are present, the pink colored charged particle. To differentiate, they are represented in 2 different colors as pink and green. Okay. So here the number of protons in helium are 2 and neutrons are only 1. So its atomic mass is 3. So helium 2, 3. Now here in this atom there are 2 protons and 2 neutrons. So its total mass is equal to 4 and the isotope is He24. So what are the isotopes of helium? He23 and 24. So helium can exhibit 2 isotopes and lithium. Even lithium also will exhibit 2 isotopes and its atomic number is equal to 3. That means 3 protons are present in lithium atom. Now the isotopes which is changing here is due to the presence of neutrons. So here in the first isotope lithium 36, 3 protons are present and 3 neutrons are present. So its mass is equal to 6. Whereas in lithium 37, the number of protons are 3, 1, 2, 3 and number of neutrons are 4 in number, 1, 2, 3 and 4. So here total it is equal to 7 in number. So the atomic mass is equal to 7. So in this way lithium exhibits its isotopes as lithium Li36 and Li37. So an element can exhibit few elements exhibits the isotopes and it can be 2 or 3. But what is an isotope means? Isotopes are atoms of the same element that differ in the number of neutrons. Now when you have to define isotope, it can be defined as elements with same atomic number but different mass number are known as isotopes. I repeat, what are isotopes? Isotopes are the elements with same atomic number but different mass numbers. They are known as isotopes. And here examples of them are H11, H12 and H13, which you have seen in the previous slide. Now here in this slide you have two more new examples. There you have learned the isotopes of hydrogen, helium and lithium. Now I have given two more, that is chlorine 1735 and chlorine 1737. The next element uranium 92 235, then isotope uranium 92 238. So an element can have two isotopes or three isotopes. It varies from element to element, but in general, isotopes means they are the elements with same atomic number but different mass number. What are isotopes? Isotopes are the elements with same atomic number but different mass numbers. Thus, isotopes have posed a challenge to Mendeleev's periodic law. So here, by the existence of isotopes, they have posed a challenge to Mendeleev's periodic law. That is, when the existence of isotopes had created a problem or created a confusion in placing them in the Mendeleev's periodic table following Mendeleev's periodic law. And the next difficulty with the isotopes is that the atomic masses of these isotopes are not increasing in a regular manner. They do not increase in a regular pattern. So here, when they are not increasing in a regular pattern, like for example, when you have seen H11, H12, H13, hydrogen with just one unit it is increasing. But when you take uranium 92 235 and its isotope is 92 238. Here the atomic mass had changed with 3 units. So here we can say that the atomic masses of the isotopes are not increasing in a regular manner. So this had become difficult and it was not possible to predict the number of elements that could be discovered between two elements. So here, due to this irregular pattern of increase in the atomic masses, it had become difficult to predict the number of elements that can be discovered in the future. So to overcome this, they thought that the modern Mendeleev's periodic law has to be modified to set or to arrange all the existing elements in a periodic table. And it was done by another scientist, that is Henry Moseley. Henry Moseley gave a new property of elements, that is atomic number, and this was adopted as the basis of modern periodic table. So to overcome the defects of Mendeleev's periodic table, Henry Moseley have come up with a new property of the elements, that is atomic number, and he has adapted this as a basis for the modern periodic table. The Mendeleev's periodic table is modified and it was named as modern periodic table or Moseley's periodic table after the scientist Henry Moseley. Now let's see what is modern periodic table. Modern periodic table is based on atomic number. Now let's see what is the basis for modern periodic table, that is modern periodic law. So modern periodic law is the base for the table, and what it is the properties of elements are periodic functions of their atomic number. So according to Henry Moseley, properties of the elements are periodic functions of their atomic number. So here he has taken atomic number as the base, and he had observed that the properties of the elements are periodic functions of their atomic number. So here when he had arranged the elements in the increasing order of their atomic number, he had observed that these elements are periodic functions of their atomic number. Means the properties of them are repeating, or the properties of these elements are periodic, means which comes periodically, are known as periodic elements or periodic functions. So here the properties of the elements are periodic function. So what is periodic means? The function, that is chemical property, that is due to their atomic number. I repeat again, modern periodic law. Modern periodic law is properties of the elements are periodic function of their atomic number. According to modern periodic law, the properties of the elements are periodic functions of their atomic number. So Henry Moseley has proposed that when elements are arranged in an increasing order of atomic number, the property of the elements is periodic. Which property is periodic is the properties which are periodic are due to the atomic number of the elements. So here modern periodic law states that the properties of the elements are periodic functions of their atomic number. Now let's see what is the modern periodic table. The modern periodic table consists of 18 groups and 7 periods. So here modern periodic table has 18 groups and 7 periods, whereas Mendeleev's periodic table has 6 periods. And the groups are divided into A and B. So here it's not divided, but they are individually as 18 groups. The next point, elements present in any one group have the same number of valence electrons. So here he proposed that elements present in any one group, that is it may be element of first group or 10th group. The elements which are present in first group have the same number of valence electron, and the elements which are present in the second group have different number of valence electron. In the same way, the elements which are present in the 10th group have different number of valence electrons. Also, the number of shells increases as we go down the group. He has proposed that the elements which are present in the same group have the same number of valence electrons, and the number of shells increases one by one as we go down the group. The next point, elements present in any one period contain the same number of shells. So in a period, the number of shells for any element is same. Also, with increase in atomic number by 1 unit on moving from left to right, the valence shell electron increases by 1 unit. So what he has proposed about periods is elements which are present in any one period. Here in modern periodic table there are 7 periods present. Now when you take first period, 2 elements are present in that. So the element present in any one period contains same number of shells. So here the first element and the second element contain same number of shells, that is first orbit 1s. Whereas the second period elements, they contain same number of shells. It may be 8 elements or 10 elements, any number of elements present there. Then those elements, all those elements contain same number of shells. What there we'll be seeing further. And he also told that with increase in atomic number by 1 unit on moving from left to right. So here, since he has arranged the elements in the increasing order, it should be 1, 2, 3, 4. So the increase in the atomic number is just 1 unit. So here, with increase in atomic number by 1 unit on moving from left to right, like when you write the numbers 1, 2, 3, 4, so on. So you start from left and move on to right. So when you are moving from left to right, there is increase of only 1 unit. The same way, the elements are also arranged due to the increase in the atomic number. So here the atomic number is increasing by 1 unit. So the valence shell electron increases by 1 unit. So in a period, valence shell will have electron one by one. It adds up one by one electron in a period when you move from left to right. Whereas in group, the valence shell increases. Valence shell increases in group. Whereas in period, valence shell electron increases. Means to the same shell, electrons are added up. Okay. Like here when you say S orbital can have 2 electrons. So first element will have 1 electron in the valence shell. The next one will have 2 electrons in its valence shell. In period. The next property, each period marks a new electronic shell getting filled, and in each period new electronic shell gets filled up. So modern periodic table has the basis, that is all the elements are arranged in the increasing order of their atomic numbers in the form of table having 7 horizontal rows of elements called periods and 18 vertical rows of elements called groups. So in modern periodic table 7 periods are present and 18 groups are there. Now let's get into the details of the elements present in the modern periodic table. In modern periodic table, there are 7 periods of elements and the elements in detail are as follows. First period has 2 elements, that is hydrogen and helium with atomic number 2. And this period is known as very short period since it has only 2 elements. Okay. Next is second period. The second period has 8 elements with atomic number 3 to 10. They are lithium to neon. The elements present in this period are starting with atomic number 3 lithium, then next beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. This period is known as short period. Then next is third period. Third period also has 8 elements starting with atomic number 11 to atomic number 18, ending with the atomic number 18. And the elements present in this period, third period, are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Don't worry, I'll be showing the number of elements in the next periodic table in the coming up slide. Okay. So third period has 8 elements starting with atomic number 11 ending with atomic number 18. And it has 8 elements like second period and it is also known as short period. The next is fourth period which has 18 elements and since it is having 18 elements it is known as long period and the elements in this period are from potassium to krypton atomic number 19 to 36. The next fifth period. Fifth period also has 18 elements with atomic number 37 ending with atomic number 54 xenon and this is also known as long period. The next is sixth period which has 32 elements with atomic number 55 and ending with the atomic number 86 radon. So here the elements in the sixth period are from cesium, Cs is cesium to radon and it is known as very long period. So first period is known as very short period. 2-3 periods are known as short periods. Then 4-5 periods are known as long periods. Sixth period is known as very long period. Then what about seventh period? Seventh period has 28 elements from francium to atomic number 114, but still it is incomplete period. So here seventh period has at present 28 elements from francium, and here this seventh period is called as incomplete period because as the time passes away, new elements are being discovered and they are added up into the modern periodic table. So at present the existing 114 element is arranged in the seventh period. Till 114 elements are arranged into the 7 periods, and the seventh period is known as incomplete period. 14 elements each of 6th and 7th periods are placed separately at the bottom of the table. So here 14 elements from 6th period as well as 7th period. From these two periods, they are arranged at the bottom of the periodic table. And why they are arranged separately is due with a separate or with a unique nature, they are placed at the bottom. Now let's see what it is. The 14 elements of the 6th period from lanthanide to lutetium are called as lanthanides. So the elements from the 6th period starting with lanthanide to lutetium are called as lanthanides, and the 14 elements of the 7th period from actinium to lawrencium are called as actinides. So here these elements from 6th period and 7th period, they follow a particular series. They follow the properties of the starting element like lanthanum, and hence all these 14 elements of 6th period are together known as lanthanoids, and this series is known as lanthanide series. In the same way, the 14 elements from the 7th period which were placed at the bottom of the periodic table, they exhibit the properties similar to the actinium, and it is known as actinide series. And the elements, the 14 elements from 7th period are known as actinoids. The series is known as actinides and the elements are known as actinoids. The same way lanthanoids. Okay. So here let's revise again. The number of periods in the modern periodic table are 7 periods. The first period 2, second period has 8, third period also has 8, fourth period 18, fifth period 18, sixth period 32, seventh period at present 28, and it is incomplete period. So here you must remember that the number of elements present in each period like 2, 8, 8, 18, 18, 32. Once again repeat after me. The number of elements present in the period from 1 to 7 are 2, 8, 8, 18, 18, 32, and 7th period is incomplete. Okay? Remember this. 2, 8, 8, 18, 18, 32. Okay? Next is about groups. So here the vertical columns in the periodic table is known as group. And in modern periodic table, there are 18 groups of elements which are divided into 9 main groups. So here we know that modern periodic table consists of 18 groups, and 18 groups are divided into 9 main groups. They are 1, 2, 3, 4, 5, 6, 7, 8 and 0 group. So here the 9 groups are from 1 to 8 and the ninth one is 0 group. And the groups from 1 to 7 has 2 groups called A subgroup and the other one B subgroup. So here 1 to 7 are divided into 2 groups. So 7 twos are 14. Then 8th group has 3 rows of elements. So 14 plus 3, it is 17. Then 0 group is the 18th group. So here 1 to 7 groups are divided into two groups as subgroup A and subgroup B. Group 8 has 3 rows of elements and 0 group has only 1 row of elements. Now, when they are divided into two different groups under group 1 to 7, the subgroup A elements are called normal elements like first group, second group, third group, so on till 7th group. Whereas the subgroup elements of B are called transition elements. And lanthanides and actinides are called as inner transition elements. So here remember that in modern periodic table 18 groups are present. These 18 groups are further divided as 9 main groups from 1 to 8 and 0 group. The 0 group possess inert gases like helium, neon, argon, krypton, xenon and radon, which are also known as inert gases or noble gases or 0 group of elements. Now, the elements which are present in the groups 1 to 7, they are divided into two groups as group A and group B, subgroup A and subgroup B. 8th group has 3 rows of elements, and under these two, lanthanides and actinides are present, which are known as inner transition elements. Now let's see the modern periodic table. So by now you know that in modern periodic table 7 periods are present. So this is first period, which has two elements, hydrogen and helium. Second period, lithium to neon. Then third period, sodium to argon. Fourth period, potassium to krypton. Then fifth period, rubidium to xenon. Sixth period, cesium to radon. Seventh period is from francium and it is incomplete period. So here there are 7 periods in the modern periodic table. How many periods are there? 7 periods, and groups are 18, as you can see now. The vertical columns 1, 2, 3, 4 and so on. The numbers are given at the top. So they are from 1 to 18. So 18 groups are present, and of these 18 groups, there are only 9 main groups, that is 1 to 7 A and B. So here 1A and this is 1B. So this is 1A, 2A, then next 1B, 2B. So there are two subgroups present here. The same way third group, third A, fourth A, fifth A, sixth A, seventh A. So you must see A groups first. 1A, 2A, then next 3A, 4A, 5A, 6A, 7A, and then 0 group of elements here. In between second A and third A, B groups are present. The subgroup B elements are present here. 1B, 2B, and then back to left. Third B, fourth B, fifth B, sixth B, seventh B, and we know that eighth B has 3 rows. So these are the 3 rows: iron, cobalt and nickel family. Okay, then under this 7 periods, lanthanides and actinide series are present, and these are known as transition elements. And one more thing which you have to remember is these elements of 1A and 2A are known as S block elements, and these are known as P block elements, that is from 3A to 8 are known as P block elements, and in between S and P, that is the elements of B group, they are known as D block element, which are known as transition elements. Under them, under this periodic table, that is, there are inner transition elements, lanthanides and actinide series. Okay, I repeat again, the left side elements 1A and 2A group of elements are known as S block elements. And the elements in group 3rd A to 7th A, they are known as P block elements. In between S and P, B group elements, they are known as D block elements, which are known as transition elements. And under this, F block elements are present, which are known as inner transition elements. Okay. So left S block, right P block. In between D block. Under them F block. Okay. I repeat again. Left S block, right side P block. In between S and P, D block. Under them F block elements are present. Now, the names of these group elements together, S and P block elements together, they are known as representative elements. S and P are known as representative elements. D block elements, transition elements. F block elements, inner transition elements. Okay. Once again, repeat with action. Left is S block, right P block. In between D block, under it F block, because you need to explain about modern periodic table. Okay, have you got? Now let's see the next one. So here, basing on the electronic configuration of the periodic table, they are designed as, these are S block elements, the 7 periods, and the right side P block elements. In between D block elements, under them F block elements. The F block elements are known as inner transition elements. D block are known as transition elements. S and P together, they are known as representative elements. Okay. Hope I am clear till here. Once again, go through the video and complete the assignment which is given. The assignment questions are: write the defects of Mendeleev's periodic table. The next one, what is the basis of modern periodic table? Write few points about modern periodic table. Okay, I hope you have understood well, and when you attend the next class, get ready by completing the assignments and with the notebook. Thank you.